Several instruments have been used to write in outer space, including different types of pencils and pens. Some of them have been unmodified versions of conventional writing instruments. Others have been invented specifically to counter the problems with writing in space conditions. A common urban legend states that, faced with the fact that ballpoint pens would not write in zero gravity, NASA spent a large amount of money to develop a pen that would write in the conditions experienced during spaceflight, while the Soviet Union took the simpler and cheaper route of just using pencils. The Fisher Space Pen was actually developed independently and privately in the 1960s, NASA later purchasing 400 of the pens at $6 each. The Soviets followed as well. As with submarines before them, space capsules are closed environments, subject to strict contamination requirements. Incoming material is screened for mission threats. Any shedding, including wood, graphite, and ink vapors and droplets, may become a risk. In the case of a manned capsule, the much smaller recirculating volume, combined with microgravity and an even greater difficulty of resupply, make these requirements even more critical. Even before the Apollo 1 fire, the CM crew cabin was reviewed for hazardous materials such as paper, Velcro, and even low-temperature plastics. A directive was issued but poorly enforced. When combined with high oxygen content, the Apollo 1 cabin burned within seconds, killing all 3 crew. Strict documentation requirements accompany anything as complex as a large-scale aerospace demonstration, let alone a manned spaceflight. Quality assurance records document individual parts and instances of procedures for deviances. Low production and flight rates generally result in high variance. Most spacecraft designs fly so infrequently that they are considered experimental aircraft. When combined with the stringent weight drivers of orbital and deep space flight, the quality control demands are high. Change control records track the evolution of hardware and procedures from their ground testing, initial flights, through necessary corrections and midlife revision and upgrades, and on to retention of engineering knowledge for later programs, and any incident investigations. When the flight also has scientific or engineering science objectives, low-quality data may affect mission success directly. Faced with these requirements, pencils or other non-permanent record-keeping methods are unsatisfactory. The act of taking permanent, high-integrity documentation itself deters gludges, workarounds, and go fever. The Apollo 1 investigation uncovered procedural and workmanship deficiencies in multiple areas, up to procedures on the pad. Temperature is moderated by a thick atmosphere. As air pressure falls, temperatures can swing more dramatically. Many early manned missions operated at below standard pressure to decrease the stresses of their capsules. Many did not have separate airlocks, instead exposing the entire cabin to hard vacuum at times. Low pressures also exacerbate contamination issues, as substances acceptable at standard conditions may begin outgassing at lower pressures and/or higher temperatures. While the Soyuz spacecraft had a 14.7 psi design pressure and could use its orbital module as an airlock, the orbital module would be deleted for planned lunar missions. In any case, a pen which was insensitive to pressure and temperature would eliminate the issue, provide margin, and allow the ability to record during extravehicular activities. The wood pencil has been used for writing by NASA and Soviet space programs from the start. It is simple with no moving parts, except for the sharpener. However, wood, graphite, and rubber are all combustible and create dust. Graphite, in particular, burns to produce dust that conducts electricity. The mechanical pencil has been used by NASA starting in the 1960s Gemini program. It can be made to be as wide as the width of astronauts' gloves, yet maintain its light weight. There are no wooden components which might catch fire and create dust. However, the pencil lead still creates graphite dust that conducts electricity.